Good morning to everyone. Myself Prabharan J, working as an assistant professor in EC department at SNS College of Technology. Today I am going to discuss an important topic in linear control system called state variables and linear discrete time systems. By the end of this class, you will be able to understand what a state variable is, define a state space model, understand discrete time systems, write state equation and output equation, explain the application of state space analysis. Yeah, let's begin. First stage of design thinking is nothing but the empathize. Okay, first, what is state? How do doctors know the condition of a patient? They check parameters such as heart rate, blood pressure, body temperature. Using these values, they can predict the future condition of the patient. Similarly, in engineering systems, we use some important variables to know the complete condition of the system. These variables are called state variables. A state variable is a minimum set of variables that completely describe the present condition of a system and help predict its future behavior. For example, in a mass spring system, position can be one state variable and velocity can be another state variable. Together, they completely describe the system. Now, let I define state variables more clearly. State variables are the smallest set of variables required to determine the future behavior of a system. In a discrete time system, signals are observed only at a specific time interval. For example, k equal to 0, comma 1, comma 2, comma 3, comma 4, and so on. Instead of continuous time, we look at separate sampling instance. The state equations predict the future state from the current state. Now let us understand the component of a state space model, that is a state vector and a input vector and a system matrices. The state vector contains all state variable. For example, position and velocity together form a state vector, and input vector contains external signals applied to the system. For examples, voltage and force and then current. System matrices, the matrices define how the system behaves internally. They are pi and gamma, and its advantage is state space representation can easily handle system having multiple inputs and multiple output. These are called MIMO, MIMO, that is multiple input, multiple output systems. Now we will build the discrete time state space model. Here state equation x of k plus 1 equal to pi of x of k plus gamma into u of k, where u of k is nothing but the input signal and x of k is nothing but the present state, and x of k plus 1 is nothing but the next state, and pi represent the state transition matrix, and gamma represent the input matrix, and output is nothing but the y of k equal c into x of k. Mm, Pi, this matrix tells how the present state changes to the next state. Gamma matrix tells how the input affect the state. C matrix converts state variables into measurable outputs. These equations are used in analysis, simulation, and controller design. Let me do one small classroom activity. Here you can see the question on your screen. Your job is find the value of the question mark position. After creating the model, we need to test it. State feedback. we use feedback control to improve system performance and state estimation. Sometimes all state variables cannot be measured directly. In such situations, observers such as Kalman filters are used. Our goal is stability, accuracy, and robustness. Let I discuss the example of state variables. Consider a mass spring damper system. The two important state variables are variable 1 position, that is x1, state variable 2 velocity x2, and together position and velocity x1 comma x2 fully describe the motion of the system. If we know position and velocity at any instant, we can predict the future behavior. This is the power of state variables. Let me see the advantages of state space method. Why do engineers prefer state space analysis? Handle MIMO systems easily, suitable for complex systems, applicable to time varying system, non-linear systems, modern control systems, useful for computer based analysis and simulation. Therefore, state space representation is widely used in modern control engineering. Let I discuss the summary of this lecture. State variables describe the complete condition of a system. Discrete time system use difference equations. State equation predict future states. State space model use pi, gamma, and C matrix. State space analysis is powerful for modern control systems. Now we are in the assessment quiz part. Let I check your understanding through this assessment quiz. Here we have two assessment quiz. First is the state equation of a linear discrete time system is option. Which option is correct? Which one is correct? Option A, option B, option C, option D. Option B is correct. And second question is linear discrete time system are commonly represented using option A, option B, option C, option D. Which one is correct? Option C is correct. That is difference equation. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.